Hi everyone, this is the walkthrough for the November 29th, 2023 gas, Heart of Gold by Bill Murphy. This is a killer Sudoku, so in addition to normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box, we also have a bunch of cages, and the number in the corner of the cage gives the sum of the digits within that cage. So these two digits sum to 5 because that's the total. These three sum to 23. And before I get started, I wanted to mention a feature in Sven's Sudoku pad, which is this killer calculator under the advanced settings. If you turn that on, it gives a little drop down here. And if I select a cage, say the 10 here, it will tell me all of the ways that I can make 10 in 2 cells. If I select the 7, it will show me the one way that I can make 7 in 3 cells. So if you don't want to worry about the math or memorizing combinations, that is there as an option. But let's get started. And we saw with the 7, there's only one way to do that. And the same is true for 6. 6 is the minimum for 3 cells because we can put 1, 2, 3, and that adds to 6. We can't put any other digits or we'll go above 6 or have repeats or require 0 or something like that. 7 is also limited to 1, 2, 4. On the high end, 24 is the maximum we can make in 3 cells. We can do 9, 8, 7. And 23 also only has one combination, which is 6, 8, 9. Now we also have some 2-cell cages that are somewhat limited. So 5 and 2 cells only has 2 possibilities. We can have 1, 4 or 2, 3. Same here. And 15 in 2 cells can be 6, 9 or 7, 8. And same here. And hopefully you're noticing now that we have a bunch of quads. So 4 cells that can only be 1, 2, 3, 4. 4 cells that can only be 6, 7, 8, 9. Whenever we have that, that means those 4 cells have to be from those digits, which means those digits can't appear anywhere else. So these are also going to be low because we have all of our high digits. We can do a little something with that up here, which is kind of interesting. The 5 has 2 possibilities, but if we tried to put 2, 3 here, well, now we would have 4 cells that need to contain 1, 2, 3, and obviously that's impossible. Another way of looking at it is we have 1, 2, 3, 4 in these cells, and 4 only appears in these 2 cells. So this has to be 1, 4. As soon as this is 1, 4, we can eliminate 1 from these cells, which means 1 is here, which eliminates 1 from these cells, which places 1 here. We can do the same thing with the 15 and the 24. The only place for 6 in this quad is in the 15 cage, so we need 6, 9. We can eliminate 9 and place 9 here. We can eliminate 9 and place 9 here. Same trick with this 5 cage. The only place for 3 in this quad is in the 5 cage. So that has to be 2, 3. Eliminates 2 and places 2 here. And the only place for 7 in these 4 cells is in the 15 cage. So we need 7, 8. Gets rid of 8 here and places 8 here. Now, there are other ways into this puzzle that don't involve all these quads. So if you didn't see the quads, that's fine. There are other ways to do it, but that is something to look out for with Killer, especially because you have sort of limited combinations of digits that can go in cells. But yeah, the 8 gave us the order of the 6, 8. The 6 is going to give us 9, 6. And the 2 down here gives us 4, 2, which gives us 1, 4. So what do we have left? We have 3, 4, 5. Neither of these can be 4. This is the only place for 4 in the row. Up here we have 5, 6, 7, and we have 2 6s, so these aren't 6, this is. The 6 disambiguates 9, 6, 4 disambiguates 1, 4. Alright, the 2 here gives 3, 2, the 8 gives 7, 8. And is there any more basic Sudoku we can do? Maybe there is that I'm missing, but I'm going to look at something else now. I'm going to look at this 11 cage. Normally there are 4 possibilities for 11. However, we have a bunch of low digits in the column. So we can't have 2, 9, we can't have 3, 8, we can't have 4, 7. The only thing left is 5, 6. And we know the order from that 6. The 5 gives us 7 and 5. The only thing left in the box is 4. It has to go with a 3 to make 7. And that gives us 2, 3. This 9 cage is also limited. We have an 8, 7, 6, so we can't have 1, 8, we can't have 2, 7, we can't have 3, 6, we must have 4, 5. And we know the order from this 4. 5 gives 3, 5. Our last digit is 6, and that has to go with 7 to make 13. And that disambiguates this cage. Lots of symmetry, as is common in a bill puzzle. This is not totally symmetric, though, so do be careful when you're solving puzzles that look symmetric. Make sure that they actually are totally symmetric in the logic. But this column we need 1, 2, 3. We have 3 and 2 here, so that's 1. Here we need 7, 8, 9. We have 7 and 8. In this column we need 3, 4, 5. We can eliminate the 4 there. Here we need 5, 6, 7, and we can eliminate the 6. This 9 is resolved because we only have 3 and 6 left in the box. Unfortunately, they add to 9, and the 6 here disambiguates the order. Here we have 4, 7, adding to 11, and the 4 in row 3 tells us the order. These are 2, 5, 7. That can't be 7. These are 8, 9. To get to 10, we need 1 or 2 to go with the 8 or 9. I should say 9 or 8. These are also 1, 2, but we have a 1. Actually, we have a 9 down here. 8, 9, 2 to go with the 8. This is 2 and 1. We get a 5 to go with the 7. So this is where the symmetry breaks a little bit. We need 3, 5, 8 here. We have 3, 5. So we have 8 and 3, 5 pair. The 2, 5 gives us 7. The 2 here gives us 5 and 2. The 5 gives us 3 and 5. We're left with 1, 4 in this column, but we have a 4 there. 6, 9 in this column, but we have a 6. And these are 3, 7, 8. We can do a little cleaning up of our pencil marks. Got 2 6s here. Places a 6 there. And we have another 4 here. Oop. Another 4. Places 4 there. The 5 places 3, 5. This is not 3. And now in this row we have a 7, 8 pair. These are 2, 9. The order. These are 1 and 9. So 9 there. Apologies if my voice is a little off. I've got a little bit of a throat thing. 1, 8 in this column. We have a 1 here. So that is not 8. 2 gives us 3, which gives us 7, 8, 7, 8, 3, 5, and 7. And that's the solution. So hope you enjoyed that.